Good morning, good afternoon, everybody. My name is Kevin Stone. I'm excited to share the progress we've made at MSD on what we call algorithmic process optimization, or APO. If you're in the US, you'll know us as Merck. However, we're internationally known as MSD, Merck Sharp and Dome, to be compliant with the Merck Group in Germany. Next slide. My group operates in process research and design, and that is how we choose to make drug molecules. And in process research, our currency is decision making. In design and optimization of a synthesis, there's just far too much decision space to be explored with constrained resources. So what does active learning do for us? It allows us to explore more space and make better, less risky decisions. You can advance. What type of decisions do we make? We use APO to model a variety of outcomes, extending beyond productivity into metrics of cost, greenness, and quality, which is of vital importance, right, to pharma development. And you can advance. Although the highlight of this talk is going to be, the code that we open source this year after years of development, I also want to describe our overall strategy too, which kind of frames our motivations here. For 80% or more of our applications at MSD, we actually seek to leverage our software as a service partner, Synthetics, to bring APO to the masses. I'm not in the business of maintaining a GUI or filling IT tickets for hundreds of end users, right? I want to work in the technology area and then work with a vendor to scale that, even if that means we pay them to do so. And so Obsidian, which we've developed, is our technology sandbox. And it's where we can work on fringe cases and on the cutting edge with a long-term vision of influencing vendor solutions to commercialize it back to us. And this scalable versus flexible two-prong approach, we've been calling our box truck and drone model to tech dev. You can advance. Using this approach, we've seen an explosion of implementation this year. Our super user team has supported now more than 20 steps on live pipeline programs this year alone, which has led to more than 10 optimization campaigns actually realized in the lab. We're proud to report that our APO community now contains more than 60 active users. And all of this huge upswing is a consequence of the results. It works. We find it works really well. I'm proud to share that every single campaign we've undertaken has successfully improved optimization targets under budget, ranging from 25 to 50% experimental reductions relative to DOE and RSM. You can advance. One of the clever ways we've motivated engagement was an interactive learning experience in February, which we called the Optithon. We created a simulated problem to optimize virtual tomato growth using a 5-parameter function derived from engineering and physics. We challenged users to budget 30 evaluations to maximize their outcome using whatever tools they prefer. And what we proudly showed and taught people was that within this realistic budget, APO tools vastly outperform traditional methods. And you can see that here with the Synthetics tool versus factorial DOE, comparing the top 5 performers from either approach. The next slide. And now I'll showcase our open source code. I'm aware there are a variety of tools in the community at this point, and our API is not unlike something you can find elsewhere. But I'll highlight 2 features that I see as distinguishing today. One is a fully usable web app, which you can completely privately deploy on your company servers. So free off-the-shelf end-user solution today. And second, we've focused pretty specifically on explainability and interpretability, so a lot on visualizations and SHAP analysis. And we've built this tool exclusively while using it on real pipeline problems. And it's been built by scientists who work in the lab. We believe that this has strengthened our solution. So to close out, this is really just the beginning. We have a lot more on our 2025 roadmap, which is in development now. And I'm excited to believe that we'll bring some new ideas to the table next year to solve some currently unaddressed problems. So thanks to the core team at MSD, thanks to our partners at Synthetics, and thanks to the organizers for inviting us.